Did you know that all the matter you can see only makes up 5% of the cosmos? If everything you can observe is just a tiny fraction, then what in the flying is all the rest? Plus, how big is the universe? Is it infinite? In today's video, we're diving into your unique home, the observable universe. We'll tackle those burning questions, explore the concept of light cones, uncover the true size of the universe, and discover what's lurking at the edges of the universe. Yes, there's more than one edge. These are the questions humans have pondered for millennia, and by the end of this journey, you'll have a deeper understanding of reality that could give you an edge in the survival of the fittest. Let's kick things off with the Sunset Conjecture. We touched on this in another video, but it's crucial for understanding how the universe is uniquely perceived by each of us. Imagine you're at the beach. The sun's golden rays reflect off the water directly towards you and simultaneously towards the person next to you. This simple phenomenon can be explained by two profound ideas behind the conjecture. First, your observable universe, which is just the slice of the greater universe whose light has reached us so far, is a giant sphere unique and centered on you where everything you see happens in the past. Second, although the greater universe with a capital U, which refers to everything that exists whether or not we can see it, has no clear center, at the center of your own observable universe lies your idea space, or your mind, hidden from the outside world with uncountable depth and zero measure. Let's break each part down, starting with the first. Everything you see is in the past because light travels at a finite speed, about 186,000 miles per second. It takes time for light to get from point A to point B. This means that when you look at a distant star, you're seeing as it was years ago, not what it is like right now. For example, the light from our sun takes around 8 minutes to reach us. So we're constantly seeing how the sun was 8 minutes ago. Similarly, light and the gravitational effects from the black hole at the center of the Milky Way galaxy took 26,000 light years to reach us. So it's showing us its state from around 26,000 years ago. This raises a profound question. If everything we see is in the past, then how far back in time can we actually see? Hold that thought, more on that soon. Now, the second part of the Sunset Conjecture states that at the center of your observable universe lies your idea space, a physics-based model for your mind. Your idea space is uncountable or impermanent and has zero measure, which means that it looks like nothing to everybody else. For instance, don't think of a pink elephant. You probably thought of a pink elephant. It's vivid in your mind, but no one else can see the exact image that's in your mind. So, with your mind at the center, what's at the edge of the observable universe? That's like asking, how far back in time can we essentially see? Well, since everything we observe is a glimpse into the past, and the farther we look, the deeper into the history we peer, the most distant point we can see marks the beginning of time itself, the Big Bang. Yes, you heard that right. Although the Big Bang happened in the past, since everything we observe is also in the past, the Big Bang is still effectively happening at the edge of our observable universe. NASA's James Webb Telescope is tasked with exploring these very edges by studying stars and galaxy structures from just 400 million years after the Big Bang. To put that into perspective, the universe is around 13.8 billion years old, so we're looking at the first 3% of its lifespan. Comparing that to a human lifespan of 78 years, that's like studying humans when they were just 2 years old. But unlike humans, we can continuously witness the past creation of the universe across every single layer, from a black hole 26,000 light years away to the effects of the Big Bang that are constantly reaching us after traveling for 13.8 billion years. Unfortunately, we can't directly see the Big Bang because the universe was opaque for the first 380,000 years. So, physicists study the cosmic microwave background directly to better understand the early fiery moments of the universe. Overall, the big takeaway is this. Much like a sunset, the edge of everyone's observable universe, the Big Bang, is unique to them. When you overlap two spheres representing different people's observable universes, each experiences their own singularity sunset, their own personal Big Bang. To better grasp this reality, let's introduce light cones. The intersection at the center represents the present moment P, with anything above it noting the future and anything below it noting the past. The incoming diagonals show light coming in, while the outgoing diagonals show light that's coming out. Overall, the edges of the bottom half of your light cone represent your observable universe, stretching back to the beginning of time, the Big Bang, and has your idea space at the very center. Light cones move forward through time via world lines, or the path that you're following right now in this crazy thing we call life. For more on light cones, then check out the book, The Idea Space, linked below. Remember when I said earlier in the video that matter only makes up 5% of the universe? That 5% includes all of the atoms that are in the standard model. According to the European Space Agency, the universe is composed of 68% dark energy, 27% dark matter, and 5% baryonic matter, or atoms. Dark energy is believed to drive the constant expansion of space. It's akin to uncountability or impermanence. What makes dark energy so unique is that its density remains constant as the universe expands over time, unlike matter and radiation, which decrease in density over time. Imagine inflating a balloon while keeping the amount of air inside the balloon the same. The air density clearly decreases. Unlike this example, as the universe expands, the dark energy density stays the same. It's as if dark energy is being continuously poured into space at a constant density, causing everything to expand. How much dark energy? No one really knows. That's a problem called the cosmological constant problem, and we'll dive fully into it in another video, so make sure to subscribe. Since space is mostly empty, dark energy pushes almost everything away from us. Distant galaxies are receding from us because dark energy is pushing them away, much like a ridge pushing the floors apart at the bottom of the ocean. The most fascinating observation that comes from this is Hubble's law, which states that the farther away something is, the faster it recedes from us. This leads to the concept of the Hubble radius, the point where space itself is expanding faster than the speed of light of 186,000 miles per second. An object emitting a signal beyond the Hubble radius, which is around 14 billion light years, will forever remain unseen because it's moving away too fast, so the light will never reach us. So, the two edges or boundaries of our universe are the Big Bang in our observable universe, which represent the past, and the Hubble radius of today in the greater universe with a capital U. Now, since everything we see in the observable universe is from the past, those points we're observing now are actually in a vastly different location due to the universe's expansion. If we were to map out how large the observable universe is today, considering where those points have moved since the light we last saw left them, estimates suggest that it's a giant sphere with a radius of 46 billion light years. Now, let's come back to our sunset. Every one of us experiences a different perspective of reality, from a sunset to their own singularity sunset, the boundary of their unique observable universe, the Big Bang. Legendary music producer and creative genius Rick Rubin unknowingly captures this concept beautifully when referring to the source, which is responsible for all of our ideas. He states, "If you have an idea you're excited about and you don't bring it to life, it's not uncommon for the idea to find its voice through another maker. The idea's time has come." Although the greater universe has no center, your idea space or mind lies at the center of your own observable universe. Your idea space, the unique way you perceive your observable universe, is the wellspring of your creativity and innovation. So, embrace your unique perspective, delve into your idea space, and take action on thoughts that resonate with you. Don't let your ideas remain in the shadows. Bring them to life and let them shape your reality. Thank you for tuning in. If you like this video, make sure to like, subscribe, and hit the notification bell so you won't miss our latest video. Words are hard, aren't they? Yeah, so do all the things that you know how to do on YouTube, but you don't do because, you know, it's YouTube. But do it for me this time because I love you and I'll give you a cookie. And then we'll learn about the Big Bang in the next video. Who doesn't love learning about Big Bangs? Yeah, I do. This cat does. You guys can't see the cat, but he's having fun. All right, peace.